Go. We're done. Problem 11.7. A firm with 14% weighted average cost of capital is evaluating two projects for this year's capital budget. After-tax cash flows include depreciation are as follows. Okay, so we have project A is negative 6,000. You can see it down here on a timeline if you like. 6,000, and we have 2,000 each year. Okay, project B is negative 18,000 with $5,600 cash flow each year. So it says calculate the net present value, internal rate of return, modified internal rate of return, payback, and discounted payback for each project. So here we have our net present value for project A. We just said our rate. Our rate is our weighted average cost of capital, H2, and I locked it. That's what I did there so I could copy it over later. Okay, and our value 1 here is D4 through D8, so that's our $2,000. And then I had to go in afterwards and put this plus D3 right up here in the formula bar. It would add it back in right. So we find our net present value is $866.16. So let's just try and do it for B. I'll just cancel it out. Find our formula. Okay, so we want to find net present value. Here I've been using it, so I can just put it in there. If not, I could type it in there and it would find it for me. Net present value. Hit OK. And the rate is our weighted average cost of capital. H2, okay. Our values, we come down and click in the value. Okay, values will be these right here, E4 through E8. And then what I'll do is I'll just click OK. But I need to have that added in to find our net present value. Hit OK, and so we found our net present value is $1,125.25 for B. Okay, internal rate of return for A, all our values. B, just use our internal rate of return function. Modified internal rate of return, same way. We just put in our each value, and then now we have to put in our assumes reinvestment at our weighted average cost of capital. Okay, find 17.12 and 9.24. Okay, now we're going to look at the payback for each project. You can see have put the payback calculations in with the timeline, but also did it here in the columns. So just for a regular payback for A, equals, to find this value is just equals, and this negative 6,000 plus this 2,000. So that's how much we have left to pay as our cumulative right there. Okay, whenever it gets to 0, that's where it pays back. Well, this one just pays back right exactly at 3 years. Okay, so it's 3-year payback. Now the discounted payback. I've done it a little different than I did the previous problem. Basically, when we're discounting this $2,000, we're just finding the present value of the $2,000. So our present value, and I put a negative number in here to keep them positive. I put a negative. Our present value equals of, and here's our rate, which is our weighted average cost of capital, which I have up here. Okay, all K 19 is for our we have our rate and then our periods, and I just put K19 as 1 because it's just one period, and our payment is 0, and our future value is this L19. is our future value. And then hit enter, and that just gives us the present value of this 2,000. Okay. Now to find our cumulative cash flow, we just add this cell and this cell to get negative 4,000. Now, let's see if I can show you I use the present value function, okay, and I put a negative in it to keep it positive because we need to add it back to this negative number to find our cumulative. So I'll put a negative in front of it all here, and then here's my rate, which is our 14% cost of capital. Now our periods, now for this is just 2. Our periods are 2 because we're discounted back 2 years. All right, no payment involved here, and our future value is the L20 or 2,000. So we say okay, and we see our present value of this 2,000 discounted at 14% is $1,538.94. So our cumulative is the 2,000 when we add our cumulative here plus what we paid back. So now we can see, after we do the rest of these, we can see that our payback with our discounted payback happens between years 4 and 5 because that's where it turns positive somewhere. So to find our discounted payback, all we have to do is say year 4, this year 4, this year 4, plus, and then I'll make our 172.58 a positive, so I'll put a negative in front of it, divided by this 1,038.74. And that gives us a discounted payback of 417 for A. Okay, I've done the same thing for B, and we find our payback is 3.21 years. And see, it takes a little longer to pay back than A, which was 3 years. And we find our discounted payback is 4.58 years. Okay, and you see it pays back a little bit longer also. So you see how we discounted each one of these back, and then here's our cumulative. So that's the payback and the discounted payback of each one. Okay, now I'd also ask, assuming the projects are independent, which one would you recommend? Okay, both NPVs are positive. So that means they're both going to make money. They're both good projects. So we could recommend them both. We can also see that our internal rate of return is over the hurdle cost here of our weighted average cost of capital. So they can both be accepted. That's a good criteria for acceptance. Now our modified internal rate of return, A is over the hurdle rate, B is not. You notice B is not. So we might, just value. That's our main criteria for acceptance of a project. But if they're independent, we could say, yes, we could accept either project. Project C, or part C, if the projects are mutually exclusive, which one would you recommend? So now mutually exclusive projects mean we have to select either or, one or the other. So if you could just choose which one of these, if you just had to choose which one would you want to accept? Well, the criteria we use, and it's the best criteria, is net present value. And so from looking at net present value, we see we're going to select project B. Now looking at internal rate of return, we might say we'd select project A, but that would be the wrong selection. We're going to select project B over A. And D, notice the projects have the same cash flow timing pattern. Why is there a conflict between net present value and internal rate of return? Why is there a conflict here? Well, the big reason is because the cash flows are so much bigger and we're discounting these back. And it shows the amount that they've been discounted. You can see it when we go to discount these back here. You can see how much we take off. And so that affects our internal rate of return along with our modified internal rate of return. If they're independent, we're going to choose them both. If they're mutually exclusive, we're going to choose B.